All right, we're going to run through some examples here from our next section in 5.2. So here's example 1. Use the Pythagorean identity, sine squared theta plus cosine squared theta equals 1 to find cosine theta. Here's one of our Pythagorean identities, and it is on page 504. It comes from the Pythagorean identity, and that's why it's called Pythagorean identities. All right, there's some other ones we'll see in a minute. Right? And so we know what sine theta is, right? And so if we were to take that into our example, right, we have 7/8 squared plus cosine squared theta equals 1. And what this really means, this is sine theta squared. That's what that really means. We put the square in front to make sure we know what's on the sine and not theta squared. So just something that we write. If I square these now and try to figure out what cosine is, right? 7 squared is 49. 8 squared is 64. Plus cosine squared theta equals 1. I'll subtract 49 over 64. Maybe, I don't know if you'll be able to see this or not here. Right, if I do 1 minus 49 over 64, right, I'm going to get 15 over 64. So cosine squared theta equals 15 over 64. To get rid of the square, I'm going to square root. So cosine theta equals, and I square root both. So square root 15 doesn't come out even. I can leave that. And then square root 64 is 8. And there's our cosine. All right. Over here with our sine, all right, same thing. Here's another example. So I've got square root 21 over 5. That's squared plus cosine squared theta equals 1. If I square root 21, square 5, 25. And now if I subtract 21 over 25, right, cosine squared theta now equals 4 over 25. Get rid of my square. And I've got square root of 4, which is 2, square root of 25, which is 5. Cosine theta equals 2/5. All right. Example 2 here. All right. Here's our other Pythagorean identities. All right. They're on page 504 in your box. You don't need to memorize them, but you need to know where they are and to use them. Okay. So it says use an identity to find the value of each expression. Do not use a calculator. Okay, so first of all, when I have ones that are multiplied together, like an A, cosine 53 degrees, secant 53 degrees, let's change all of our secants or cosecants or cotangents to sines or cosines. So what this really means is cosine 53 degrees times, and what is secant really? Secant is 1 over cosine 53 degrees, right? Secant is 1 over cosine. So I have cosine in the numerator and denominator. They cancel. And I end up with a 1. Here, you start to recognize that that is sine squared of an angle plus cosine squared of an angle. Angles are in radians. And so when they're both squared, same angle, equals 1. All right, down here is a little bit different. We have a cosecant squared and a cotangent squared, and so we're looking at this bottom one. Well, we don't have a cosecant minus cotangent, but if I subtract cotangent from each side, I end up with 1 equals cosecant squared theta minus cotangent squared theta. And this is what I actually have, right? So here's cosecant squared theta minus cotangent squared theta, and it equals 1. All right, example 3. All right. Make a note, cofunctions are listed on page 505. You can look those up. Right. Here's what your box would look like. Right? It's a big list of just these. And if we're using radians instead of degrees, instead of 90 degrees, you should have pi over 2 in there. So if we're finding a cofunction with the same value as the given expression. Okay, so here's the cofunction I know for sine. All right, sine theta equals cosine 90 minus theta. Well, our theta is 19, right, from right here. And so sine of 19 equals cosine 90 minus 19. And so sine 19 actually equals cosine 71. Now y. Okay, so if here's my right triangle and here's my 19-degree angle, and if I label this y and x and h for hypotenuse, right? If I were to take sine of 19, right, sine of 19 is opposite over hypotenuse, or y over h. My 3 angles in a triangle add to 180, so that's 71 degrees up there. If I were to take the cosine of 71, that equals adjacent over hypotenuse. And you can see those are the same, and that's where these cofunctions come from. All right. So if we use B, all right, I check out my identity sheet, all right, find out which one I'm using. So cosecant theta equals secant theta, 90 minus theta. Okay, so cosecant 35 equals secant 90 minus 35. Can't do that. Find your calculator. 90 minus 35. And we have cosecant 35 equals secant of 55. All right. Our tangent down here. All right. So now we're in radians. So instead of 90, we're going to use pi over 2. My identity is tangent theta equals cotangent pi over 2 minus theta. And, right, so I've got tangent pi over 7 equals cotangent pi over 2 minus pi over 7. And so tangent pi over 7 equals, okay, so now here I use my function. Okay, so I need to figure out what pi over 2 minus pi over 7. And if I turn that into a fraction, no, doesn't work. All right? So I kind of have the decimal form of it, but what I have, right, is there's pi in them. So if I divide by pi and convert that to a fraction, all right, there's my fraction. Okay, so I have 5, cotangent 5 pi over 14. All right, last one, right? And you may have lost you a little bit on that one, so we'll try it here. So my identity, cosine theta equals sine pi over 2 minus theta. Okay? So cosine 3 pi over 8 equals sine pi over 2 minus 3 pi over 8. Cosine 3 pi over 8 equals, okay. So I'm going to do pi over 2 minus 3 pi over 8. All right, so I get a weird decimal. I divide pi out and then convert it to a fraction. And so it's really sine, and that's 1 pi over 8. I divide it out the pi, so when I write my answer, I make sure I add it back